Okay, a transport plane traveling at constant velocity of 50 meters per second at an altitude of 300 meters releases a parcel when directly above a point X on level ground. Okay, calculate the flight time of the parcel. Okay, let us just look at the question A first. Now, if you here is the picture to assist you. Okay, so what kind of projectile motion is this parcel? Okay, if you look at this parcel, the parcel actually travels from here going down. So this is clearly a horizontal projectile. This is a horizontal projectile. So one thing we can see from here is look at the initial velocity. For horizontal projectile, okay, right, just see this. Okay, we put it down here. Okay, so we know it is a horizontal projectile. Horizontal projectile. Okay, look at the. All right, we just make two components. Okay, horizontal projectile has two components. It has x and y components. Okay, so now horizontal projectile. The initial velocity. Let's talk about the initial velocity for horizontal projectile. It has only the x component velocity. The initial velocity is only x component. So we can say the initial x velocity is the initial velocity itself, which is 50. And the initial velocity for y component is 0. This is the most important thing in horizontal projectile. Okay, the initial velocity only has x component, no y component. So the uy is 0. This is the most important thing. So we can label over here. Yeah, we can so like doing a projectile motion question, we can label. Okay, firstly we label of course the acceleration, and then the initial velocity, and then displacement. Put in the value into the table form. Okay, so for projectile motion, okay, normally for projectile motion, ax is 0 because x component is a constant velocity, right? We can say just write over here, projectile motion, the x component is a constant velocity, whereas the y component is free-fall motion. Free-fall motion. So x component is a constant velocity, so no acceleration at ax 0. And then free-fall motion, y component is a free-fall motion, so ay is negative g. This is the thing you must know already. Okay, so now another thing is horizontal projectile. Okay, horizontal projectile, the initial velocity, okay, ux is equal to u, which is 50. Okay, we can put into the table here, and then uy is 0. Okay, now okay, what else? Okay, look at this horizontal projectile. It has two components, right? Okay, maybe put it down here a bit. Okay, this projectile motion, it has two components. It has the x component and it has the y component. We can imagine like this. Yeah, we can imagine like for example, box over here. Okay, the box coming down, free-fall motion coming down, and also x component is a constant velocity to the right. Okay, so okay, displacement. Let's talk about displacement. Okay, for x component and y component. So here it gives us the 300 meter altitude. That means you see that the parcel is 300 meter from the ground. So this 300 meter is the displacement in y component. That is sy. That is sy. You see that? So this one, sy, we need to put positive or negative. How to know positive or negative? So this, look at the this one. This is the initial, or we call origin, and this is the final. Yeah, origin, and this is the final. Displacement is the distance between initial and final. So this final is below origin. Below origin, so we put a negative sign because the final point is below origin. So it is negative 300. Negative 300. That's the y displacement. So we can put over here. Okay, we can put sy is negative. Remember, why negative? Because the final is below the origin, below the initial. Okay, so negative 300 meter. Okay, that's it. Okay, so so now how to find the time of flight? Okay, one thing we can know from here is this time. Okay, this time x is equal to time y. Because we know that the time for this parcel to go to the right, as this parcel to go downward, they complete it at the same time. They complete it at the same time. All right. So time is the same. So we want to find the flight time of the parcel. That means the time of flight of the parcel, the time of the projectile. So we need to find. So now the question is, we need to find the time of flight, or we can say time of the projectile. Can we do it? Yeah, we can do it, right? So the time of projectile is actually the same as the time of the y component and also the time of the x component. So which component can help us to find the time of projectile? We find ty or tx. Yeah, which component has enough information or more information to help us get the time? Which one? Okay, which one? Yeah, this one only has 2, this one has 3. This one has 2 information, this one has 3 information. Of course, we always need 3 information to get the one unknown, isn't it? So we use y component more suitable, okay, to find the ty. Then only we can get the type of projectile. Let's do it. Okay, let's do it. So we start with the question A. We start with the y components. Start with the y components. So for question A, for the free fall motion, so we use the y component. We use the y component. Okay, so what equation is suitable? SUAT. So this is SUAT. So SUTAT. So SUTAT formula is S equal to UT plus half AT square. S equal to UT plus half AT square. So put in the value here, negative 300. Okay, and then U is 0. Okay, U is 0. Right, U is 0. And then half A is negative G. A is negative G. And then put the time there. So you can get the time. Okay. So let's calculate. So our time is equal to 7.82 second. That's our time. Okay, that's our time taken. So the time for free fall motion is 7.82. Let's just put inside this value. 7.82 seconds. So this time is the time for the free fall motion to reach the ground. So the time for the ball to reach the ground, the time for the free fall is the same as the time of projectile. Okay, I did show you a video clip before showing you two objects, one projectile, one free fall. They reach the ground at the same time, isn't it? So what I can say is the time for free fall is the same as the time for projectile. Okay, so we just now the question asked for what is the flight time of the parcel. Yeah, what is the time of projectile? What is the time of projectile? So time of projectile is equal to the time of free fall. Right? So time of projectile is equal to time of free fall, which is 7.82 seconds. This is the answer. So this is the answer, time of projectile. This is the answer. Is it correct? 7.82? Yeah, 7.82 is correct. Yeah. Also, the time for free fall is also the same as the time for the horizontal constant velocity. Yeah, because these three component, these two components with the time projectile, they all have the same time. Okay, so this is the horizontal motion, this is the vertical motion, this is the projectile motion. All of them have the same time. So this one also 7.82. We also can write it. Yeah, this is 7.82 projectile. The horizontal motion also 7.82. Now you see we link already from the y component. We link to x component. So from x component later on we can find we have three information already. We have 1, 2, 3 information. So from 3 information we can get the displacement. Later on we can get the horizontal range because we already have 3 information. The time we take from the y component. So this is how we always link. We always link between the two components, between the x component and y component, by using the time. You understand? By using the time. So from one component we get the time first. And then that time can be used to the other component, which is the x component, to find the missing value. Understand? We also later on can find if the question asks about a final velocity, we also can find the final velocity for x and final velocity for y. So we can find many other things more. Yeah, we can find many other things more. Okay. Now, can you get the concept? That's the way to do the projectile motion questions. Okay. The key is to find the time first for any component. Sometimes it starts from the y component to get the time. Sometimes it starts from the x component. Sometimes it starts from the x component to get the time. So look at which component has more information first. We always start with the component with more information. Okay. So that is how we do it. So we got the answer for A. Now let's look at B. The velocity of impact of the parcel. Oh, velocity. So this question, now he wants to find velocity, okay, which is the final velocity of impact. Impact, that means on the before reaching the ground. So this is the one. Yeah, we need to find this final velocity. Remember, this velocity is a vector. A vector, you cannot just give magnitude. You must give both magnitude and direction. If you just give magnitude only, then you lose marks for direction. You see, the answer also have direction. You see that? Even though here didn't mention specifically one direction, but it is understood velocity is a vector. Vector, you must give both magnitude and direction. Okay. So now we need to find this velocity, the magnitude, and also the direction. Okay, I can draw it like this. Okay, this is the theta we need to find. Yeah, it seems to be below the positive axis. Okay, so we need to find these two values. So how to find the V? V, it also has two components, as we can see. Okay, as we can see, it has also two components. It has the x component and y component. So V, you have Vx, and also we have Vy. Yeah, so Pythagoras theorem. Okay, Pythagoras theorem. So we need to find Vx and Vy. All right, Vx and Vy. So that's why we need to add another row to find the velocity, Vx and Vy. Okay, so how do we do it? Okay, how do we do it? Okay, so let's start. Let's do question B. Yeah, let's do question B. So let's start with the x component. Let's start with the x component. Now, how to find V? So we can use the formula V equal to U plus AT, isn't it? VU AT. We can use V equal to U plus AT. You know, actually, it's a good way. You always write the subscript, like just now the y component. You write the subscript there. This is sy, this is uy, this is ay. It's good practice to write like that. Better you write like this x component. Better you write the subscript there. This vx, ux, ax. Then it's more neat. Yeah, it's your work is more neat. Yeah. So now AX0, AX0. So what happened? X component AX0. So AX0, that means 0. So Vx is equal to Ux. Vx equal to Ux. Also, we already know the final velocity in X is equal to the initial velocity in X. Why? Because the X component is always constant velocity. Constant velocity. So the final velocity should be equal to the initial velocity. Okay, so the final velocity is equal to initial velocity. The initial velocity is 50. You see that? It's 50. Just put 50 meter per second. Okay, that we got the x component. Now let's look at the y component. Okay, let's look at the y component. So what formula we use to find Vy? We can just use V equal to U plus AT because we already have the time. You see that? We have the time. So we just use V equal to U plus AT. Now, better you put the subscript there. Vy, Uy, Ay. Okay? Vy, Uy, Ay. So now, okay, Uy is 0. You see that? Uy is 0. Okay? And then, yeah, you know, it's good you put in the table, in the table form, so that your work looks more systematic. Yeah, you gather all your information in a table form. You have you have everything, your acceleration, AU, ST, V. So this table will help you a lot in solving the problems for projectile motion. Okay, gather your information in a table first. So now we want to find Vy. Okay, Vy. So Ay is negative g. So just substitute. Yeah, Ay is negative g, which is negative 9.81. Remember, the g itself is a positive value. Okay, the g itself is a positive 9.81. So just put in g with 9.81. So you get negative 9.81. Time taken is 7.82. So calculate what's the answer. Yeah, 9.81 times 7.82, and then you have negative sign there. So it is a negative 76.71 42, as many decimal places as possible, meter per second. So I got the Vy. So I got the Vy. Actually, you can also just write down the value over here. Okay, once you got the value over here, you can put in the value here so that it will assist you to find the next piece of information. You understand? You can just put Vx is 50 already. You also can put the Vy. Okay, Vy has negative. Negative means it's going downward. Yeah. So 76.7142. Okay. Okay, put in there. So now we want to find V. We want to find V. You understand? Okay, look at this Vx and Vy. Okay, Vx is a positive value, but Vy is a negative value. Is a negative value. That means what? That means Vx is going to the right. Okay, Vx component is horizontal and positive is going to the right. Okay, this is a positive 50. And then Vy is negative. Y component is vertical. Negative means going downward. Going downward. So this is a negative 76.7142. So just put it over here. Okay, so what is our resultant? So our resultant is over here. Okay. So this is our V. We need to find this V. Okay, and this is angle theta. Okay, so the magnitude of the velocity is actually square root. Just take our 50, yeah, our Vx square plus, and then the Vy is negative 76.7142. Okay, remember the negative after square disappear, become positive. So we just you know, Pythagoras theorem, and what's the answer? What's the answer? I got the V is 91.57 meter per second. Okay, 91.57. And then let's find the direction. This is the magnitude. Remember, a velocity, a vector, you must give direction also. So what's the direction? Let's find out. Okay, for direction, okay, we already got the magnitude, but we need the direction also. Direction, we use tangent theta. Tangent theta, we just take the y component divided by x component. Remember, we modulus it so to make it positive value. Yeah, we modulus it to make positive value. The Vy got negative, we need to make it positive by modulus. Okay, so now let's continue. Let's calculate. One thing is you must remember this. When you want to find, you need to find theta, not tangent theta. You need to find theta. So theta is you must anti-tangent. After you got your answer, after you divide, you got your answer inside. Okay, you got your answer here. Don't forget to anti-tangent. Okay, anti-tangent to get angle theta. Yeah, we want to get theta. We don't want to get tangent theta. Yeah, don't forget the step here. So the theta is equal to, so anti-tangent. Okay, anti-tangent, you will get, yeah, the angle is 56.9 theta, degree. Okay, 56.9 degree. So this is below the positive x-axis. So you must write this is below positive x-axis direction. That's the answer. Okay, so is the answer correct? Look at okay, look at the, yeah, this one. Yeah, we predicted it's like this, isn't it? So yeah, it is correct. Yeah, we you know, maybe you can drag this to the top there, right over here at this part. So you can see, can you compare? Can you see that? Indeed, we got Vx is positive, going to the right. Vy we get negative. Negative means going downward. Going downward. So this is the final velocity we need to find. So the same as this one. Okay, and we got the magnitude when the direction is 56.9 degree below the positive axis. Yeah, it is below the positive axis. So that's correct. So let's look at the answer. Is it correct? So the answer is 91.57. 91.57. Yes, 91.57. Now next, the angle is 56.9 below positive. 56.9 below positive. Is it? Yes, 56.9 below positive. That's right. You must write this. Remember, you must write the things behind. Don't just give the degree. Don't just give the degree. You must mention this word below positive x-axis to show that it is at which quadrant, to show that the vector is in which quadrant. Okay, you must write this. If you don't write this, you will lose marks. Okay, now the last thing is the question C. Question C, what's the distance from x to the point of impact? So what is the distance from x to the point of impact? So this is about what is it about? It is about the distance from x. That means from x, distance from x to the point of impact. That means you want to find this one, isn't it? From x to the point of impact. So it is Sx. It is the horizontal range. You want to find the range, which is the R. Understand? You want to find the range Sx. So this is the x component. This is the x component, which is this one. We have so many information here already. You can either use the v, you can use the t, you can use the u, you can use the a. We have 4 information to get the one unknown. So there are many equations you can use to find s. You can use v equal to u plus you can use s equal to ut plus half at square. You can use v square equal to u square plus 2as to find the s. So there's many information. Yeah, so that's why I recommend you to draw this table. Yeah, gather all the information at one place, so that easy for you to build equations to find any unknown value, yeah, or fill in the blank, fill in the empty space, at any point. Okay, and you can always refer to each other. So now let's look the question C. So the question C, question C, I just drag this a little bit over here. Okay, now I want to do the question C. I want to find Sx, the range. Yeah, find the Sx. So how to find Sx? So question C, how to so we use the x component for this one. You see, we always do by components. You see that? We always do by component. We do x component, we do y component, we do separately. Yeah, we don't do combine. And then we do here. Oh, what is this? Yeah. Okay. So sorry. Just drag it over here. Yeah, a little bit. Okay. We always do by component. X component, y component. Only when resultant we combine them. Yeah, Pythagoras theorem. Normally we do by component, y component. So for this case, for question C, we do x component only. Yeah, we don't even look at the y component. We don't even look at the y component this time. Okay, we only do the x component. So how to find the Sx? So just use s equal to ut plus half at square. Remember, this is all x components, so you need to put subscript below each terms. Yeah, acceleration in x component is 0 because constant velocity, acceleration 0, constant velocity, acceleration 0. So become s equal to ut only. And then continue. This is 50 times the time, which is 7.82. We got the time. That's why I asked you to fill in the blank here. Put the time here. You got for y component already. You just put the time in the x component also, so that then you can use this time to find the displacement in x. You see, very simple. So 50 times this 7.82. So I get the answer is 391 meter. 391 meters. Is that correct? That's the horizontal range from x to the point of impact. Is that correct? Yes, from x to the point of impact is 391 meter. 391 meter, which is this horizontal displacement. Okay, so that's it for projectile motion questions. Always draw a table to gather all the informations. Refer by using the time. Yeah, time x and time y, time projectile, all of them are equal. Okay, so that's it for these questions. Bye.